In this section of integration, we're going to learn something called definite integral. So it's a little bit different from the previous step, integration. You will see two tiny numbers at the tail, at the integration tail. So these are the two numbers. So when you have an integration with two numbers, we call it a definite integral. So what does the two numbers do? And how do you handle the two numbers? And what is the interpretation with the two numbers there? So we got to go slowly on this part first. So first of all, let me show you how I will handle the two numbers first. So usually, so I'm going to give you a simple example. So if you take a look at example one, the two numbers are 3 and -1. So normally you got to put the bigger number on top and then the smaller number below. So big on top and small below. So if they didn't give you correctly, they gave you the smaller one on top and the bigger one at the bottom, we got to do something about it. So later on, I will tell you what to do about it. So right now, okay, take it as it's a correct format right now. The number on the top is big one. The number on the bottom is a smaller one. So how do you go about doing this? So you do your integration as per normal. So this part here, it looks like your basic integration formula number two. So you integrate. So you return a power, divide by the new power. So what do you get when you integrate 5? You get a 5x. And usually we also get a constant. So I'm just going to show you with the constant. Okay, so after I integrate, okay, I will put a 3 and -1 there. So what exactly does it do? So it's very simple. If you take a look, I'm going to put in the top number. I'm going to put in the top number as x equal to 3. Then I'll put in the bottom number. So how I handle this will be, this one is x equal to 3. Here will be x equal to -1. And then I'm going to subtract. So in a way, this one, I will call it a top minus bottom. So you do a top minus bottom after you integrate. So you put in the top number, you put in the bottom number, and then you subtract off. So it's always a subtract. So what do you get eventually? So if you look at the first bracket, you will get 51 plus C. So if you look at the second bracket, you will get a -6 and 1/3 plus C. So you go and open up the big bracket, you will, C will cancel away, C minus C, that will cancel away. So it will be 57 and 1/3. So the handling of definite integral will allow you to end off with a number. And if you realize, the constant is actually being cancelled out. The constant is being cancelled out. So in actual fact, right, sometimes when we present definite integral, we can do without the plus C. Because anyway, it's going to be cancelled out. Okay, so that's how we handle a definite integral. The steps are very simple. You just integrate, and then do a top minus bottom. The top number sub in, subtract the bottom number sub in. So it's actually quite simple, but there's a lot of chance to make careless mistake. Because sometimes you integrate wrongly, or sometimes you punch calculator wrongly. Okay, but we also do need the interpretation. We need the interpretation. So when I do this, I get a 57 and 1/3. So what does it actually represent? It actually represents area under graph. So let me show you. So first of all, this part will be the equation. This is the curve. So I'm just drawing the curve. I anyhow draw the curve. It's not supposed to be like this. So this is the curve. And then this is the x equal to 3. So x equal to 3 is a vertical line. And then this one is x equal to 1 minus 1. That's also a vertical line. And the 57 and 1/3 is actually this whole area. The area on the graph. Below the graph, sticking on the x-axis. So this area is 57 and 1/3. So generally, when we find a definite integral, the values you are getting is actually the area that's under the curve. Under the curve, but it is connected to the x-axis. The area is connected to the x-axis. Okay, so this is how we interpret a definite integral. So later on, we'll look more into the area under graph idea. So right now, you need to understand that definite integral will enable you to get a value. And the value is area under graph. So at this moment, right, you need to know how to get the value correctly first. Then we slowly extend it to the idea of area under graph. So before we can do this, you got to look at some properties of the definite integral. Okay, so some properties of the definite integral. So if the two numbers are the same, it actually ends up as a 0 because you got no area. Because when you got area under graph, if the x are both the same, so this is x equal to a, this is also x equal to a. So there is no area. There's no area. So just now I got an area because I got two vertical walls. So the x equal to 3 and the x equal to -1 is like two vertical walls. So the two wall come up with an area. So but if the two lines are the same, that means you don't have any area in between. Okay. Now just now I mentioned that for a definite integral, the bigger number has to be on top. The smaller number has to be at the bottom. So if it's not the case, if you need to flip the numbers, you can flip it with a negative sign. So for example, if let's say you've got -3, 2 fx. Okay. So the smaller one is on top. You want to flip it at the bottom. You can change the position. You change the position, but you add on with a negative. So that's the property. This is one of the more important ones because you must remember this property. The bigger number on top, the smaller number below. If it doesn't match the property, please do this. Now, this is another property that you will need to know. So to better understand this property, I will draw for you. So I'm going to draw a fx. So I'm going to draw a fx. Then I'm going to have a, b, c. So let's look at this part first. X equal to b and x equal to a. So this is this piece of area. Okay, then here, x equal to c and x equal to b. It will be this piece of area. So these two pieces of area is actually the same as, take a look. If you add up these two pieces of area, it will be the same as from x equal to c all the way to x equal to a. So you're adding up the two pieces of area. Okay, the next two properties are the easier one. For such definite integral, you can move the numbers in and out. A constant can be moved in and out. So a very simple example. So for example, 3 minus 2, 2fx. You can move the 2 out and to make your indefinite integral easier. Okay, so you can move a constant in and out of a definite integral. Okay, another property also quite simple. So if you do a definite integral on adding two functions, you can split them into two definite integral. You can split them into two separate integral. One definite integral and another definite integral. Of course, you can also minus them. Okay, so these are the main property. But the more common one will be number 2 because you need to flip the numbers. Okay, and pulling out a constant in between definite integrals is also quite common. Okay, so from here later on we'll show you I will show you more examples. So right now you just have to see the idea as definite integral will give you a number, and that number is representation of area under the graph. So we'll talk more about area under graph subsequently. So right now just be mindful about the property first. So I will show you the numerical example in a bit.